So this is about the work and energy situation of a 10 kg block that it is released from rest on the horizontal surface from B, and then the spring has been stretched a distance 0.5 meter from the neutral point, and the coefficient of friction is 0.3. So what we need to calculate is the velocity of the block as it passes through A, and also as well as the maximum distance x when it left A, which the block go. So when we are dealing with spring, there's always a very crucial question you need to ask. The spring is stretched or unstretched. Okay, so they're talking about the stretching of the spring. So let's say this is a spring, and then we all know that the spring can be stretched or even being compressed. So whatever the spring actually is stretched or compressed, there it is leaving his neutral point. Neutral point is mean that the spring doesn't being disturbed at all. So that's why we say that it is a neutral point. Okay. So it's a neutral point, there will be no spring force. At the same time, they won't have any work generated by the spring. Because we know that the spring force, it really depends on the distance of the spring being stretched or being compressed. So that's why if there's no distance, the spring being stretched or compressed, definitely spring force or work generated by the spring will be zero. Okay, now take a look at our situation over here. Our situation A, it is the neutral point. So, which means when at A, the spring it is not being compressed or stretched. But if from A to B, so we know that the spring will be stretched and spring force or work generated by the spring will be there. And the interesting thing is the whole situation starting point it is at B. So A just indicate that it is the neutral point of the spring. So if you analyze dynamic, we know that now our situation starting it is at B, and then ending there will be at C. Okay, so but basically we have two ending points. One is at C, another one that will be at A. So A at the same time also it is an ending point. Because if you look at our question over here, A is saying that velocity V block that pass the point A. So now if let's say we were to analyze A, that we are talking about the block from B and then go to A. So that will be the situation, and then, or I may not sketch in that way, but that will be causing so many confused. But definitely, if that will be the situation over here, our free body diagram we got to be very clear over here. At B, because the spring is being stretched 0.5 meter, so definitely at B we will have our spring force. So our spring force at B And we know that the formula calculate the spring force, that will be K is the stiffness of the spring, and then X is the distance. So by that, then we know that K is 300, and then our X, that will be 0.5. Okay, and the direction of this spring force that will be acting, definitely it is behind. Because if the spring being stretched from A to B, there will be always a force actually heading backward, that means to the air direction, to pull it back. So basically that will be something that actually we can talk about. So from the spring force that we can see over there, and then at the same time we know that to B, from B to A, then we will also have a friction, because he is saying that the coefficient of kinetic friction of the block and the plane, that will be 0.3. So we will have a friction force that we know that there will be mu times the n. N is the neutral point, or not neutral point, sorry, that will be the normal force acting onto it. So if I want to talk about the n, that we'll need to look for this n, okay, because that's our free body diagram. And then that we will be have our to know the n, then we will have definitely of the wick over there. So in this situation, that very fast we know that our n, that will be equals to the mg. So if I want to calculate the friction force, then that will be very straightforward over there. So if I try to calculate that, then my mu will be 0.3, and my n, that will be mg. So the block is 10, and then the g is 9.81, so we can calculate that very fast. So now we have plotted the free body diagram for the block at point B, and then we know that it's moving backward over there, and we would like to know the velocity at A. So now kinematic may come into the picture, because at B we know that the velocity, that will be 0, because the question mentioned at B that it starts from rest. So that is something that we know that they will be equals to 0. And then A we don't know. And that's definitely that what we need to calculate over there. So now we can call out the work and energy equation very fast. So that will be this, and T we know that it is denoted as the kinetic energy, and then the U will be the energy, force times the distance, okay, the general energy of the whole system. So right now we know that our position 1, that will be B, and my position 2, that will be A. So we all know that. So position B, because V is equals to 0, if I write the formula out, kinetic energy, that will be that, okay, equals to the kinetic energy at A. And because VB is equals to 0, so that means my kinetic energy at B, that the whole thing will become 0. So then this I can say that they are all gone already. Okay, so now for the general energy moving, and we know that will be for the x direction because it's moving backward. So if we're moving backward, we know that there is some of the force we can put into the calculation. What are the force that is happening on the x direction? Definitely that will be the spring force. That will be the spring force and also the friction. So if I put that will be the force, the spring force at B times the distance. The distance from B to A, that will be 0.5. Okay, and then my friction, of course, also the same. My friction will be dF, so I'm moving a bit for the space. Okay, more space for that. Okay, so then my friction force that will be D times the distance. So the distance also is 0.5 because it's reached A. Okay, so right now we have to determine which is positive and negative. So if let's say I am saying that the direction over here that will be positive, because the whole thing is moving backward. There's no issue if you want to use the reverse. So then you just have to make sure that everything is clear, because you look at the whole situation and it is moving backward, so I would like to take that as a positive. That will be much more clear to me. Okay, so if that's the case, then my spring force, of course, that will be positive, and my friction, that will be negative. Okay, so by that means that we can do a calculation, and the spring force we can calculate. That will be, referring back just now what we are having, that will be 1/2 300 times 0.5 times 0.5. Okay, so that will be my whole first, and then minus, that will be the 0.3 times mg times 0.5. Okay, so that will be equal to 1/2. So m, that will be 10, and then there will be V power 2. So the mg over here, that very easy, we will get that also, because m, there will be 10, and then g will be 9.81. So if we look for the whole equation over here, or the mathematical expression, so we only have one unknown, VA. So just use the calculator to resolve everything over here. Then we will get our VA as 2.13 meter per second. Then we solve part A.